In this video, we are going to give you an in general detailed explanation about nuclear power plants, nuclear reactor and how it works. And we'll see their basic applications too. We'll be covering the following topics in today's video. First, what is a nuclear power plant? Second, how a nuclear power plant works. Third, about PWR and BWR reactor and their applications. Fourth, the main components required for a nuclear reactor. And fifth, some real-life applications of nuclear technology. A nuclear power plant is an industrial site that generates electricity from nuclear power, released in the form of thermal energy through a nuclear fission chain reaction inside a vessel of a nuclear reactor. The main component of a nuclear power plant is the nuclear reactor, which contains the nuclear fuel, usually uranium, and has systems that make it possible to start, sustain, and stop the nuclear reaction in a controlled manner. But exactly how a nuclear power plant works? The way a nuclear power plant works is similar to a conventional thermal plant, where thermal energy is obtained through the combustion of fossil fuels. In a nuclear reactor, however, this energy is obtained via nuclear fission chain reactions of the uranium atoms from the nuclear fuel. The liberated thermal energy is used to heat water at high pressure and high temperature until it becomes steam. This steam spins a turbine connected to a generator, which transforms the mechanical energy of the turbine into electrical energy. There are different types of nuclear reactors, but two outstanding designs are present in over 80% of the almost 450 operative units in the world. First, pressurized water reactor (PWR). Second, boiling water reactor (BWR). Now, let's talk about PWR reactor. It is important to keep in mind that in nuclear fission, the nuclei of heavy atoms are bombarded with neutrons and then decomposed into smaller and lighter nuclei. When this happens, they release the energy that binds the neutrons and protons that compose them, and then they emit 2 or 3 neutrons. These can produce more fissions as they interact with new heavy nuclei, which will then emit new neutrons and so on, so that the reaction sustains itself. This multiplying effect is known as nuclear fission chain reaction. We can also use a boiling water reactor. BWR is a type of light water nuclear reactor used for the generation of electrical power. It is the second most common type of electricity generating nuclear reactor after PWR, which is also a type of light water nuclear reactor. The way a nuclear power plant works can be simplified into 5 stages. The uranium fission takes place inside the nuclear reactor. It releases a large amount of energy that heats the coolant water circulating at very high pressure. This water is transported via the primary circuit to a heat exchanger that produces water steam. This steam is transported to the generator turbine set via a secondary circuit. Once there, the vanes in the turbine move the alternator and the mechanical energy is transformed into electricity. When the water steam goes through the turbine, it is sent to a condenser to cool off and become liquid water again. The water is then transported to the new steam generator to become steam again inside a closed circuit. The main components for a nuclear reactor are fuel, moderator, cooling water, control rods, shielding, and last but not the least, safety elements. Fuel. The material usually enriched with uranium dioxide, where the fission reactions take place. It is used simultaneously as a source of energy and of neutrons to sustain the chain reaction. It is presented in a solid state in the form of cylindrical pills encapsulated into metallic rods a few meters long. Moderator. Water that slows down the fast neutrons generated by the fission, which leads to a new fissions and the sustainment of the chain reaction. Cooling water. The same water that induces the fissions as a moderator, which now serves to extract the heat generated by the fission reaction from the uranium in the fuel. Control rods. The controlling elements in the reactor. They act as neutron absorbers. These rods are made of indium cadmium or boron carbide and make it possible to constantly control the neutron population while keeping the reactor stable. They also make it possible to stop the reaction whenever necessary. Shielding. It prevents the leak of radiations and neutrons from inside the reactor to outside. Usually, shielding is made of concrete, steel, or lead. All nuclear power plants have multiple safety systems to prevent the leak of radioactivity to outside. These systems include the containment building. Nuclear technology has a large and various real-life applications. It has multiple applications that are fundamental to our daily life. The best-known applications are medicine and electricity production. But there are others in such diverse fields such as agriculture, industry, and art. These applications have a large presence in our day-to-day life, and in future they'll be even more relevant as research is increasing their possibilities of application and justifying their use. Currently, nuclear technology is being used in medicine sector, hydrology sector, agriculture, space mining, industrial sector, etc. Talking about space exploration sector, one of the main applications of nuclear batteries is space navigation. It involves feeding the instrumentation of terrestrial satellites and planetary probes with more powerful generators so that they can reach nearby planets and send information to Earth. Unmanned trips to planets beyond Earth's solar system were carried out in missions with robotic equipment fed by the electricity produced by the radioisotope plutonium-238. This isotope has a half-life of 87.74 years. It can remain active long enough to power space missions for several centuries. Did you ever hear about nuclear batteries? They are used in interplanetary trips and can last several years, which is really amazing and interesting. The use of isotopes and radiations in modern industry is highly important to the development and improvement of processes, measurement, automation, and quality control. Currently, almost all branches of science use them in different ways. For instance, tracers are used in expensive industrial equipment to obtain information that makes it possible to extend its operative life. Another application involves obtaining X-rays of the internal structure of certain pieces to check their quality without damaging or altering the material's composition. Hope you have got an idea of nuclear power plant working methodology and their various applications in real life. Thank you.